In this video, we are going to look at what causes wood pole degradation and the tools for inspectors to conduct inspections. Also, if you don't know already, this video is part of a playlist that contains all the videos for this wood pole inspection course. So if you're interested in viewing the entire course and not just this particular video, please visit the playlist link that I have left in the video description below and start with the first video. So let's get started in this particular section, degradation and tools. Let us start with degradation first. Decomposition fungi in the groundline area are the most common cause of wood pole structural failure. Carpenter ants, termites, and woodpeckers can all cause problems to the poles as well. Let us start with fungi. Fungi are primordial organisms that develop billions of spores, which are small seed-like structures. The above spores potentially germinate on a bit of wood and develop what we call the hyphae, which are thread-like filaments. On the wood, the hyphae produce enzymes to break down the lignin and cellulose, which are used as food by the fungi. For such wood fungi to begin the infection process, 4 requirements must be met. And if one of those factors is not met, deterioration or decay will not occur. So what are the 4 prerequisites? Well, they are, first of all, there needs to be an oxygen supply. The temperature needs to be 0 to 32 degrees Celsius. There needs to be moisture over the saturation threshold of the wood, which is more than 25 to 30% moisture, as well as there needs to be a source of nourishment, which in this case, it will be the untreated portion of the wood pole. Now, these situations are most common where the pole comes into touch with the ground, and to a lesser extent at the pole's top. At the ground line, the infection can begin inside the pole and work its way out, or it might begin on the surface and make its way to the core. And in the latter, we call this the external decay. The consequence of decay in both circumstances is the disappearance of sound sections of the wood, lowering the wood's initial load-bearing capability. From the first admission of the hyphae into the wood cell to the ultimate disintegration of the wood itself, decay includes all stages of infection on the pole. While severe degradation is apparent to the human eye, the early incipient phases of this type of decay are actually not. The principal decay fungi that infect softwoods are what we call the brown rot fungi. It is brown and crumbles when dried at its advanced stage. Although it's frequently referred to as dry rot, the wood must have been moist enough at one point to allow the fungus to thrive. Temperature affects the growth of wood-rotting fungus in the same manner that it affects the growth of regular green plants, as it moves faster in warm weather than it does in cold weather. Temperatures for optimal development vary from 17 to 35 degrees Celsius, according to tests that have been conducted in various labs and utility companies. At freezing or slightly above freezing temperatures, all fungi show little or no development. However, temperatures considerably below the freezing threshold do not kill most wood-rotting fungus, and they can survive the cold of winter in a dormant form, and if other requirements are met, resume active development again when the temperatures rise again. As temperature rises over 35 degrees Celsius, growth would slow and eventually stop for most fungus as temperature slightly above 37 degrees Celsius. Fungus can be killed totally by prolonged exposure to temperature slightly over the maximum for growth, or 37 degrees Celsius in this case, or even short exposure to temperatures that are substantially higher than the maximum. Temperature, time, and moisture content all determine the actual death point for these fungus. Now, before we move on further into our course, let us take a brief look at our sponsor for this course. Now, as an engineer, especially when I first started in my career, I really felt overwhelmed the list of documents that we need to do on top of our technical work. Yet, these documents are very important in our career as it is the more prominent thing that displays our credibility to management and to our clients if we so decide to become an engineer consultant, which is where the real actual money is. Now, I don't have these tools available to me when I first started my career, but now PM Milestone has created this package of all the professional templates that you need so that you can focus more on the technical aspect of your career. These templates are tried and tested by real professionals, so you should feel confident in using them in your career to present your best foot forward in front of your manager or clients. These templates are also updated periodically, and I think their last update is just 2021, so they're not going to be out of date or context to the present times, as these people are serious in getting the most professional product to meet your needs. They're also very confident of the quality of these templates too, as they offer you their product completely risk-free with 60-day money-back guarantee if you are not satisfied with it. So, if you are interested in this product and would also like to support me in creating these courses on YouTube in the future, please check out their product using the link in my video description titled Course Sponsor PM Milestone 2.0. Aside from fungi, there are several types of insects that affect the integrity of growth. So let us start with carpenter ants. Now, the most common insects seen during the pole inspection procedures are carpenter ants, and they reside in colonies and make nests in poles for shelter, but they don't actually eat the wood. Amount of sawdust at the foot of the pole would usually indicate that there are presence of these carpenter ants, and these ants may often be observed swarming around poles looking for food. Carpenter ants may be found across North America and other parts of the world as well, and they come in a variety of sizes, which they actually would help to determine the colony's age. So, for example, larger ants would actually indicate that there are in proximity a very developed ant colony. Carpenter ants are more common in locations where the water table is high, and they make their nest in damp wood and seek for high moisture locations in and around wood infrastructures. And before ants start constructing nests, incipient or extensive rot is usually present within the wood of the pole already. Carpenter ants have around a black waist that range from around 1/4 to 3/4 inches long. Now, the next type of insects I want to talk about are the damp wood termites. Now, they're normally cream in color, but they also may be brownish in color as well, and they're usually around 1/2 inch to 3/4 inch long. The damp wood termite constructs its nest in the wood that it feeds on, and the nest, which can reach quite high up in the pole, are generally densely packed with pellets. Termites that feed on damp wood are more commonly seen in coastal locations. Now, the third type of insects that I want to talk about are termites again, and these are called the subterranean termites. And these termites are similar to the damp wood termite, although they're a bit smaller, which is around 1/4 inch long. Now, the colony prefers to reside under the ground and only attacks poles in search of food. These termites' usage of mud tunnels to go from their nest to a food supply, or a wood pole in this case, are surely evidence of indication of their existence in the wood pole. So be sure to look at mud tunnels. Termites may be found throughout all of North America. However, if you look at the northern parts of North America, these are actually rarely found along in the wood poles. And despite their differences in size, both dampwood and subterranean termites have bodies that are comparable in shape and breadth. And wings are also present in the reproductive adults. The last type of insects that I want to talk about are the wood borers and the beetles. Although pole failures due to such insects are uncommon, there are various species that may infest wood poles. Golden buprestid or soil beetle larvae may be found in older poles, and both of these bark bugs infest damaged trees or logs that haven't been peeled. Once the bark has been removed from a log, they will not penetrate it, and the presence of these beetles is sometimes overlooked until they grow and begin to depart the poles as mature beetles. Other insects frequently use these exit pores as entry points into a pole, and internal damage might be indicated by these poles. And the chewing of these beetles and these holes along these poles attracts woodpeckers as well, which we will discuss later. Standing poles with interior deterioration are attractive to pillbugs and Pacific powder post beetles as well. They're drawn to moist wood and are most frequently seen near the ground line of the pole. Both species resist direct sunshine and are normally introduced to a pole via seasoning checks. Powder post larvae construct tunnels in the heartwood beside the treated shell, whereas pillbugs make little nests and feed on decaying wood fiber. Prior to pupation and emergence as an adult beetle, these larvae may be found in the wood for up to 20 years, and in most circumstances, just a few larvae are present in any individual pole, and pole failure is uncommon due to these bugs. The presence of both of these insects does imply that there is a likely substantial interior deterioration, however. The western red cedar borer is a metallic colored beetle, on the other hand, that penetrates a tree via its branches and bores its way to the tree's pith as a larva. For around 2 years until pupation, it excavates lengthy wandering tunnels in the heartwood. It then bores to the pole surface and emerges as a beetle. Other insects and fungi may be able to enter through these exit pores. And woodpecker activity is a symptom of an infestation, since damage is always seen in the upper area of these poles. Now, aside from insects, we also have woodpeckers that we need to look out for. Woodpeckers are territorial, establishing territories in which they live and then returning to re-attack poles that have been moved. Now, there is no explanation for why woodpeckers attack wood poles on occasion, and the poles reappear to be chosen simply by chance. Woodpeckers peck on poles as part of their mating rituals, and their pecking for insects can cause holes to appear in those wood poles. Untreated wood can be exposed to moisture and spores from these woodpeckers, resulting in deterioration and a loss of pole strength. And if degradation or decay develops, it might lead to further attacks and the formation of a cavity. Woodpeckers frequently utilize the same holes for breeding in subsequent years. Small and medium-sized cavities do not cause major structural damage to the pole, but a higher number of them will. The main issue is that water entering the holes will promote fast fungal development, resulting in internal wood decay. The damage to pole lines is especially noticeable in places with deciduous trees. Poles are less likely to attract woodpeckers in regions where coniferous trees are abundant, as the trees are often going to be targeted by the woodpeckers first. So after the different modes of degradation that I've talked about, let's look at the various materials, tools that you will need for wood pole inspection. So now let us look at preservative treatments that we need to apply for wood poles. Now, the Canadian standard CSA 080 and the American Wood Preservative Association standard T-4 both address the preservative treatment of wood poles, which includes pushing preservative into the wood. Now, these standards have the same technical substance, and the treatment techniques are either going to be oil or water-based. The criteria specify the amount of preservatives that must be placed in the sapwood, as well as the depth to which the preservative must enter the sapwood. and the required depth of penetration varies by species, as the pine requires the deepest penetration, while the western red cedar requires the shallowest. To guarantee that the sapwood is properly treated, thin sapwood species are incised in the groundline region. Creosote was widely employed for the treatment of wood poles in the first part of the 20th century, after which the pentachlorophenol dominated the market until the 1980s, when CCA, or what we call the copper chromated arsenate, emerged as a major rival. Other preservatives that have found limited application include the ACA, which is the ammoniacal copper arsenate, the ACZA, which is the ammoniacal copper zinc arsenate, ACQ, the ammoniacal copper quaternary, and the copper nephenate are also part of the preservatives that have been used throughout the years. Now, oil-based creosote, penta, and copper nephenate, while water-based CCA, ACA, and ACZA preservative codes seen on the pole brands or tags are as follow. So if you see the code C, you know that the preservative creosote is used. CCA means that copper chrome arsenate is used. CN, it means that the copper nephenate is used. P is, if you see P, it means that the pentachlorophenol is used. And lastly, if you see the code S or SK, you will know that the CCA, ACA, or ACZA are used. Now, most of these preservatives can be used on most species. However, CCA cannot be used on Douglas fir because the preservatives will not permeate the sapwood. Before being treated, a pole is either branded or a metal tag of the following information is going to be attached. So the information will be like the manufacturer of the pole, the year of the pole, the class of the pole, the length of the pole, the wood species of the pole, as well as the kind of preservatives that's been applied to these poles. So now let us talk about the tools that are being used for wood pole inspection. Now, the majority of the tools required for inspecting wood poles can be found at local hardware stores. So if you're a contractor for utility companies, you can easily buy these tools within hardware stores. So let's go over each of these tools. The first, it's the chipper. So when is it being used? Well, after excavation, which we're going to talk about the process in a later video, a chipper is used to remove surface deterioration off the pole. Then another tool that you will use will be a long-handled brush. And what is it used for? Is actually used for applying preservative paste to a pole's below ground line shell. Then you will also need a tape measure, which is used to measure the circumference of the pole in various ways. And you also need a scraper, which is used to wipe up deterioration pockets on the outside of the pole. You also need a large screwdriver, and that is not for screwing screws, but it's actually used for checking for rot on the pole. You also need a 2-pound hammer, and that is to use to sound the pole to see whether there is any internal degradation, and I will talk about this in a later video. Then you also need a digging bar, which is a tool that is used to remove boulders from excavation, as well as a stapler for stapling craft paper to poles. And speaking of craft paper, you also need a utility knife that you need to use to cut these craft paper. And you will also need a trowel if you are not using a brush to apply preservative paste on the poles. You will need a tarpaulin, which is used to heap soil on lawns while digging, and an excavation shovel to dig around the pole or doing the excavation. You will need a wire brush to remove the soil off the pole once it has been excavated, and you will need a drill or an auger to drill holes in poles to inspect for interior rot pockets and preservative treatment. You also need what we call the internal treatment tank, which is used to inject liquid fumigants and preservatives into the poles, with which I'm going to talk about in a later video. And a bandage microboard, which is a 30 by 60-inch board of 12-inch plywood used to produce bandages when utilizing the trowel method, which of course I'll explain later. And the board is usually hinged in the middle to make it easier to store on a truck. So make sure that you need to make one of these through the materials that you will acquire from the hardware store. And lastly, you'll need something called a shell thickness indicator. And this is used to determine the radial thickness of sound wood on a pole that surrounds a hollow heart. And this shell thickness indicator looks like the image that is shown in front of you right now, right below the name of called the thickness indicator. When the tool is placed into the drilled hole, the indicator's toe will penetrate the rotten wood, and resistance will be felt when the tool is removed and the toe meets sound wood. On one of the two graded scales on the tool shaft, the thickness of the sound wood, or the shell thickness in this case, can then be read. When one scale is used in a hole dug at 45 degrees, the other is used in holes drilled horizontally. And lastly, let us look at materials. So for materials, there are 6 major materials that you should be aware of. Well, the first one is the craft paper with the polyethylene backing. And of course, this is used as a bandage to cover exterior paste after they've been brushed onto the pole. You also need wood or plastic dowels, which is to use for sealing holes after poles have been treated internally. You also need pole marker paint, which is actually used to identify which poles need to be replaced or stubbed. You also need rags, which is usually for general cleaning and removing preservatives from equipment and other items, as well as disposable bags made of plastics to store all hazardous things during your inspection process or your pole maintenance or treatment process. And lastly, you also need identification tags, which is used to affix to poles that list the date of inspection, the contractor's name, as well as the preservatives that it's being used. As mentioned in the introduction of this course, I highly recommend you to take my Distribution Power Engineering Fundamentals course or the Transmission and Distribution Line Infrastructure Fundamentals course to gain core knowledge of the distribution power poles that we're looking at in this course. These 2 courses will provide you not only the prerequisite knowledge that you need to understand what I'm talking about in this course better, but also provide you with essential industry knowledge that will no doubt help you propel your career to the next level. Also, upon completion of the courses, you will get a certificate of completion, which you can show to your current or potential employer that you have mastered these fundamental concepts. I have left the links to my 2 courses in the video description below, so be sure to check it out. Also, this video is part of a playlist that contains all the videos for this wood pole inspection course, so if you are interested in viewing the entire course, please visit the playlist link that I have left in the video description below. Thank you for watching, and I will see you in my other videos.